Hey y'all, we are Memphis Communiversity and we're back for another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. Today is the day, friends. Today is the day we're going to be talking about the all-important chain rule. So the chain rule is more important than the product rule, the quotient rule, and the power rule. It's the rule that we're going to be using constantly over and over and over again. You might not know the chain rule very well right now, but as we do these questions, as we practice in this video, as you practice yourself, you're going to love the chain rule more and more and more until it becomes one of your best friends. The chain rule is one of my best friends. Unfortunately, the chain rule is a little bit tricky to get working with at the beginning. Sometimes students can't spot it or they might chain too many times. But if we do a lot of practice examples, if we just know the process, we're going to be able to get better and better and better. So what is the chain rule? So with the other rules, like product rule and quotient rule, it's pretty obvious when to do which one. So the product rule, of course, is used with products. The quotient rule is used for quotients. What is the chain rule for? Well, the chain rule is used for composition of functions. So what we're going to do is we're going to take the derivative. So we're going to have something like y is equal to f of g of x. So it's going to be a function within a function. So instead of having sine of x times x squared, what we're going to do is we're going to find x squared and plug it into sine. So it's going to be sine of x squared. So that's not a product. You first plug it into x squared and then you plug it into sine. And we're going to be taking derivatives of those. So what's going to happen is the formula for the chain rule, the rule we're going to love the most, the treasure the most, what it's going to be f prime of g of x times g prime of x. And this is the chain rule. We're not going to prove the chain rule because this is calculus done wrong. We're not going to prove the theory. What we're going to do is we're just going to focus on the chain rule. So let me talk about the chain rule. So again, what's going to happen is we're going to have composition of functions. So we're going to have an outside function and an inside function. And how you take the derivative of this composition of function is you take the derivative of the outside function. What you do is you keep the inside the same. And then finally, at the end of the problem, you're going to multiply by the derivative of the inside function. So again, you're going to take the derivative of the outside function. You're not going to change the inside function in this part of the question. On the latter half of the question, you randomly multiply by the derivative of the inside function. So this is pretty complicated. It's not as easy as low d high minus high d low over low or something like that. So we might as well go for examples. But again, this is the chain rule. We might write it in the corner here because it's a pretty simple formula. The derivative is f prime of g of x times g prime of x. So let's get started. Let's do some examples. So let's take the derivative of sine of x squared. So again, just be careful. We have an outside function of sine. We have an inside function of x squared. This is certainly not the product rule. So I'm going to underline some stuff. So my outside function is going to be sine. My inside function is going to be x squared. So what's the derivative? Well, the derivative is, again, you take the derivative of the outside thing first. So what's the derivative of the outside function? Keeping in mind that sine is the outside function here. Well, the derivative of sine is just cosine. So it's going to be cosine. Then what do we put in these parentheses? Well, the rule is you take the derivative of the outside, but you keep the inside the same inside the outside, if that makes sense. So again, we take the derivative of cosine, but we're not going to write cosine of x. We're just going to put cosine of whatever it originally is. So in this case, it's cosine of x squared. Then, though, you have to multiply by the derivative of the outside on the end of everything. So we're just going to multiply by 2x. So this is the answer. Again, you take the derivative of the outside function, that's just cosine, and then you multiply on the very end of everything the derivative of the inside function. So this is where you get your chain action, I think. This sort of looks like a chain, maybe. But again, what we need to do is we just need to practice as many examples as possible so that you sort of have a sense of how things work. So my next question is going to be y is equal to, let's say, 5x plus 3e to the 7x. So what's the derivative here? Well, looks like we don't have compositions at the beginning of this one, so that's just going to be 5 because the derivative of 5x is 5. The derivative of any constant times x is that constant. But this requires the chain rule. So why does it require the chain rule? It's because there's an inside function. You don't have to do the chain rule when it's something like e to the x, sine of x, cosine of x, inverse tan of x, ln of x. All of those don't require the chain rule. But when you have an inside function, which in this case is 7x, it's not just x, you have to employ the chain rule. So what is the derivative here? Well, the derivative is you take the derivative of the outside function, which in this case is just 3e to the 7x, because the derivative of e to itself is e to itself, but we do need to multiply by the derivative of the inside function. What's the inside function here? Well, it's just 7x, so we're going to have to multiply by the derivative on the end here of the inside function. So it's going to be times 7. So again, it's the chain rule. You take the derivative of the outside function, which in this case just kept everything the same because it was e to the x, and then you multiply by the derivative of the inside function times 7. Because what is the derivative of 7x? It's just times 7. So let's try to do another one. Let's say we have y is equal to something like 8 times x squared plus x to the third. So let's take this derivative. So keep in mind, again, we have composition of functions, we have a cube, and we have x squared plus x. So usually the inside function is something in parentheses, but sometimes it's just written in a different thing like square roots or denominators or something like that. So let's take this derivative. Well, again, you take the derivative of the outside function. So what is the outside function? It's going to be the cube. And what does the power rule say? The power rule says you take a power, you drag it to the front, and then you subtract 1 from your exponent. So in this case, we're going to take the 3 down to the front. There's already an 8 here, so we're going to let the 8 and the 3 mingle, so we're going to multiply them. It's going to be 24. Then it's going to be something. We're going to subtract 1 from the exponent because that's how you do the power rule. You take the 3, drag it to the front, subtract 1, so it's going to be to the 2. What do we put in these parentheses? Well, remember, we shouldn't change the derivative of, we shouldn't change the inside. We first keep the inside the same, so it's going to be x squared plus x. How we deal with the inside is we multiply on the very end the derivative of the inside. What's the inside? Well, it's going to be 2x plus 1. So it's going to be 2x plus 1, that's the derivative. Hopefully you can see that's 2x plus 1, and you're good to go. So again, you take the derivative of the outside function, which in this case is the cube, you bring it down because it's the power rule. We subtracted 1. We did not change the inside function within the outside function. And finally, we multiply by the derivative of the inside function at the very end. Again, this can be pretty complicated, but as you take derivatives over and over and over again, you'll be more accustomed with the chain rule. Take the derivative of the outside function, keep the inside function the same thing within it, then multiply by the derivative of the inside function on the very end. And that's the chain rule. Again, let's just do as many examples as possible so we get a lot of practice. So I'm going to erase this. I'm going to erase this. So my next one is going to be y is equal to square root of ln of x. Let's just add plus 3 randomly. So in this case, again, we have a composition of functions. We don't just have square root of x or ln of x. We have ln of x shoved into square root of x. So anytime I have square root, what I'm going to do is I'm going to rewrite this as ln of x to the 1/2 because I like to do the power rule as much as possible, and you can do the power rule with square roots. So this was just a rewrite, and by rewriting, it also helps me because it's more obvious what the inside function in this case looks like. The inside function is just ln of x. So now we're ready for the derivative. So again, it's the chain rule. What you want to do is you want to identify the inside function, which is in this case ln of x. Then the outside function is 1/2. So you take the derivative of something to the 1/2. That's just the power rule. Let's take the 1/2, drag it to the front. So it's 1/2. Let's not change the inside within the thing. So it's going to be ln of x to the negative 1/2 because you subtracted 1 from the exponent. So we took the 1/2, brought it to the front, subtracted 1, but we did not change the inside function within the 1/2. And then at the very end, you need to multiply by the derivative of the inside function. What's the inside function in this case? Well, it's ln of x, so it should be times 1/x. And that's the answer. Again, take the derivative of the outside function, keep the inside function within the outside function the same, so that's why we kept it as ln of x. We didn't multiply, we didn't change this to 1/x, for example, right now. And then at the very end, you multiply by 1/x. A very complicated process, but as you get used to it, the questions become easier, and easier. So let's do another one. Let's say we have something like, I don't know, y is equal to 5 to the inverse tan of x. So again, it looks like we have two functions here. We have a 5 to a something, and we also have inverse tan of x. Keeping in mind that when we do this, this is not power rule, even if it's something to a power, because this is the a to the x rule, because x is in the exponent. So this is the rule where the derivative of a to the x is a to the x times ln of that number, ln of a. So let's try to identify inside function, outside function. That's probably the best step to do. What's the inside function? Well, the inside function is just going to be the inverse tan. If you want to identify the inside function, the outside function, and you're having trouble, just imagine if you plugged in a number, and you don't even have to compute it, you just have to tell what happens. So let's say if I plugged in 0, how would I find this number? Well, first I would find inverse tan using like pandas and things like that. Then I would do 5 to that power. So in this case, what's the inside function? The inside function is going to be inverse tan. And what's the outside function? It's going to be 5 to something. So let's take the derivative with chain rule. It's going to be take the derivative of the outside function. So that's going to be 5 to something times ln of 5. Again, it's not the power rule because it's a number to the x. Then what should we put here? Well, we don't put the derivative immediately. We keep the inside function the same within the derivative of the outside function, if that makes sense. So in this case, we're going to write 5 to the tan negative 1x. So it's going to be 5 to whatever was originally there times ln of 5. Here's where the chain rule comes in. On the end of everything, just a nice little dot there, we're going to multiply by the derivative of inverse tan. So in this case, it's 1 over 1 plus x squared. That's a memorized derivative, the derivative of inverse tan, and this is the answer. So that's how it works. Again, we take the derivative of the outside function, which in this case is 5 to something. We kept the inside the same, so it's 5 to the inverse tangent of x times ln of 5. This ln of 5 is just part of the rule of the derivative of 5 to the x. And on the outside of everything, when we chained it, it's times 1 over 1 plus x squared. Let's keep doing more examples though, because again, in my opinion, this is pretty complicated. So I'm going to erase this. So one of the things that some students do is, one of the common mistakes is that they'll chain too much because they get so excited to do this process that they're just taking derivatives, and they're going to be like, I'm chaining everything I see. But that's not always the case. That's actually wrong. And I'll tell you sort of a hint on how to avoid chaining too much. So my next question is going to be y is equal to tangent of x squared. So let's take this derivative. Let's add a 4 in the front just to make it a little bit spicier. But hopefully you see which one is the inside function, which one is the outside function. The inside function in this case is going to be x squared. The outside function is going to be tangent. So in this case, we're going to start taking the derivative. Again, the rule is you take the derivative of the outside function first. What's the derivative of 4 times tangent? Well, you memorize your derivatives. The derivative of tangent, of course, is secant squared. So it's going to be 4 times secant squared. What we're going to put in these parentheses? Well, we put the original inside function. So it's going to be x squared. Finally, we're going to multiply by x squared because that's the chain rule. Off the very end, you multiply by the derivative of the inside function. So it's going to be times 2x. And that's all it is. What some students unfortunately do is that they chain too much. So they'll multiply by the derivative of 2x. So what I encourage students to do is try to remember that you multiply by derivatives of what is originally in the question. So notice that x squared is originally on the question that is presented to us. So that's why I'm multiplying by its derivative times 2x. What some students will like to do is they'll like to multiply by 2 because they want to multiply by the derivative of this thing. But we introduced 2x as we took this derivative. Notice that 2x is not in this question. So because 2x is not in this question, we're not going to multiply it by its derivative. You only multiply by derivatives of things that are originally in the question. So we had tan, so we wrote down that derivative. We have x squared, we have the derivative right there. We are not going to take the derivative of this because this is, we introduced this. We wrote this down. It was not in the original question, so we shouldn't touch this. So this is the final answer. So one more basic chain rule, and then we're going to sort of mix things up to make life a little bit more fun. So in this case, we're going to have y is equal to secant of, let's say we have secant of x to the 4th. And then we can have plus 3x. So this is going to be my question here. So what's difficult about this question is because the derivative is a little bit weird of secant x. So let me remind you the derivative of secant x if you need memory. Keeping in mind that the easiest way to do this, again, is to memorize. So the derivative of secant x is secant x tan x. So what people get confused about as you're doing the chain rule is what to do with these multiple x's. But again, what we're going to do is we're just going to take the derivative and plug in the inside, keeping it the same, and on the end of everything, we'll multiply by the derivative of the inside function. So what's the outside here? It's going to be secant x. What's the inside here? It's going to be x to the 4th. So now we're ready to go for the show. So what's the derivative of secant x to the fourth? Well, again, because the derivative of secant x is this, what we're going to do is instead of writing x's, we're going to write the inside function. So in this case, it's going to be secant of x to the fourth tan of x to the fourth. So again, don't be intimidated that the rule for secant happen to have x's. Again, when you take the derivative of the outside function, you keep the inside function within the derivative of the outside function the same. So we shouldn't have like x to the fourth and x, we have x to the fourth and x to the fourth. Finally, we multiply by the derivative of the original inside function. So what's the derivative of this inside function? It's going to be 4x cubed, using the power rule. Taking the 4, bringing it to the front, subtracting 1. So it's going to be 4x cubed. We don't multiply by 4x cubed twice, even if we have 2x to the fourths, because again, you're always multiplying by things that are originally in the question. The question originally only has 1x to the fourth, so at the very end, we multiply by 1, 4x cubed. Chain rule. Taking the derivative of the outside, secant tangent, putting the inside for both of the x slots, and then finally, on the end of everything, multiplying by the derivative x to the fourth, which is 4x cubed. And this concludes our basic derivatives. After we take this derivative, sometimes you just have these easy derivatives on the side here, so it's going to be plus 6x. And that's all it is. This is a basic chain rule. Now we're going to do a little bit harder questions, because sometimes you have chain rule within chain rule, meaning that you have functions within functions within functions. It is a little bit trickier, but if you sort of do this process multiple times, you'll see that it's the same sort of thing. So let me erase this and let's go for harder questions. So we're going to erase this and we're going to do some harder ones. So chain rule within chain rule within chain rule. Again, chain rule is my best friend, so I don't mind if I have to do chain rule a bunch of times. So in this case, what we're going to do is we're going to do y is equal to, let's say we're going to do sine of e to this, let's take x cubed. So this is my first function. So notice that this is harder than the previous ones, because in previous ones we just had an outside function and we had an inside function. And in this case, we have three functions. We have sine, e, and x cubed. So one thing that my students, at least when they start doing derivatives, what they want to get accustomed to is they'll spend a few seconds trying to think about what's the inside function and what's the outside function. So in this case, because we have three functions, it's not just going to be inside and outside. It's going to be, I'm going to use the word outsidus, even if that's not the word, basically the most outside function, but there's going to be the outsidus. Then there's going to be the middle function, sort of, which is going to be inside the outsidus. And then finally, you're going to have the insidus function, just three functions here. So in this case, what are those three functions? Well, it looks like sine is on the outside of everything. So it looks like sine of x is going to be our outsidus function. Then the middle one is going to be e, and finally the last one is going to be x cubed. Again, if you want to identify the outside and the inside functions, what I would do is I would just plug in a number, and you don't have to actually find the number, just think about how would you compute it. So if I were to plug in 1, for example, I would first find 1 cubed, then I would do e to that, then I would do sine of whatever that is. So again, that's why sine is the outside function, e is the middle one, and finally x cubed is the inside one. So how do you take the derivative here? Well, you always deal with the most outside thing, or the outsidus. So what's the derivative of sine? Again, it's cosine, so it's going to be cosine. Then we're not going to touch whatever was originally in the sine, just like normal. So we're going to write e to the x cubed. But because of the chain rule, we have to multiply by the derivative of this function right here. So now what we can do is we can just think of this as an easier question. E to the x cubed. What is the outside? Well, it's going to be e. What is the inside? It's going to be x cubed. So we take the derivative of the outside function, which happens to be itself, unfortunately. E is kind of weird. The derivative of e to something is e to that thing. So it's going to be e to that thing. We're not going to change that thing yet. But finally, this is the inside function. So we have to, at the very end of all this, multiply by the inside function. So this is where our chain comes in. And it's going to be 3x squared. Can't draw errors these days. But again, taking the derivative of the outside, so it's cosine, keeping the inside the same, then multiplying by the derivative of the inside, which happens to be a compositional function itself. So we have to employ another chain rule eventually, but we're just going to multiply by the derivative of e to the x cubed. Then you multiply by the derivative of the inside function, the insidus, or the most inside function, which is 3x squared. We don't multiply by 3x squared, of course, because we introduced this is not in the original question. We did take derivatives of everything we could visibly see, sine and cosine, e to itself, x cubed to 3x squared using the power rule, and that's how chain rule works. So let's do another one of these questions where we have chain rule within chain rule within chain rule. So let's do y is equal to, for example, let's do, which one haven't we done? Let's do an ln again. So ln of, let's say, cosine of 5x. So when you don't have e's and when you have parentheses, usually it's a little bit easier to tell what's on the outside, what's on the inside. So in this case, hopefully you notice that ln is on the outside, cosine's our middle guy, and then nested within both of these guys is 5x. So that's going to be our most inside function. Now we're ready for the derivative. So we're doing chain rule. So how chain rule works is you take the derivative of the outside thing. What's the derivative of ln of something? It's 1 over that thing. So it's going to be 1 over all of this stuff. Because again, as you take the derivative of the outside function, you keep the contents of whatever was in the outside function the same. So in this case, it's going to be 1 over cosine of 5x. Because that's the derivative of ln. But we're not done, of course, because we have to take the derivative of cosine of 5x. So in this case, what's the derivative of cosine of 5x? Well, that's going to be negative sine, because the derivative of cosine is negative sine. Then we're not going to change this 5x and this parentheses here, because we don't change the inside function as we take the derivative of the outside function. So what's the derivative of cosine of 5x? It's negative sine of something. Then we do have to account for this 5x because we have a new inside function. What's the derivative of 5x? Well, that's just times 5. So that's our answer. Again, chain rule within chain rule within chain rule. But if you're careful, you just take a derivative, then you take another derivative, and you take another derivative, and you're just taking derivative of simpler and simpler functions because it's the inside of the inside of the inside. And that's how it works. Again, a very complicated process at first, or at least a process that takes a little bit of getting used to. So I would encourage you to do as many questions as possible. We're not done with this video. Let's do some more. So I'm going to erase this. And let's see, let's do the function, something like, let's actually go for the end. So remember that we have other rules that we need to talk about, which is of course the product rule and the quotient rule. Sometimes they're of course mixed together to add everybody to the party. So let's do this one. Let's do x to the 8th times e to the minus x. So this is my next question. So hopefully you notice that this is a product rule question because we have something times something. So I'm going to take the product rule, derivative of the first, keep the second one the same, plus keep the first the same, derivative of the second. So let's do that. Y prime. Let's underline these things. I like to underline them as I'm doing product rule. So product rule works just like normal. Hopefully you watched our product rule and quotient rule video. We highly encourage you to do that if you haven't done that already. But let's go for this. So what's the derivative of x to the 8th? Well, that's going to be 8x to the 7th. There's no need to do chain rule because it's just a simple function, x to something. If it was, for example, cosine of x to the 8th, or x plus 1 to the 8th, or ln of x to the 8th, then we would have to be doing chain rule. But because it's just a single x to the 8th, we don't have to do that. So that's the derivative of the first one. What we do is we keep the second one the same, e to the minus x. Then for the next half of the product rule, we of course write a plus. We keep this one the same, so this is going to be x to the 8th. And then finally, we have to multiply by the derivative of e to the minus x. But in my opinion, the hardest chain rule questions aren't the more complicated one, where it's just one function and one function, it's obvious you do the chain rule. The more complicated ones, and the ones that my students mess up the most, are these little chain rule questions. Things with like minus x, or 2x, or 3x, or something like that. You have to do the chain rule if the inside function is not just an x. So we have to do the chain rule when it has minus x. So let's see how that works. What's the derivative of e to the minus x? Well, it looks like it's going to be e to the minus x, because that's the derivative of e to anything. It's e to that thing. We don't change the derivative of the inside function within the derivative of the outside function. But we do have to account that the derivative of this inside function isn't just 1. So what's the derivative of this inside function? What's the derivative of minus x? If you want, you can think of it as minus 1 times x. So what's the derivative there? It's just going to be times negative 1. But it's really hard to recognize this negative 1 unless you just do these questions over and over and over again. This is my chain rule. I have to multiply on the outside of everything the derivative of the inside. So in this case, we had product rule, derivative, keep the same, the derivative, where the second derivative was chain rule because we didn't just have x, we had minus x. So let's keep doing questions like this. Let's try to mix up quotient rule and chain rule this time. So I'm gonna erase this, or not erase this, let's just write a new question. Y is equal to, let's say we have x squared plus 1, and then on the top here, we're going to have sine of x squared. So this is another question that some students mess up because they don't know how to deal with this square. This is one of those questions that it might be nice to rewrite everything. So I'm going to rewrite this. What I mean by sine squared, of course, is I mean it like this. But if I write it like sine of x squared as opposed to sine squared x, before I take the derivative, it's more obvious that I need to do the chain rule because I have an inside function and an outside function. So this on the bottom here, it's going to be x squared plus 1. Nothing changes about that. So now we're ready for the derivative. I think I can put it in this spot here. So keeping in mind that we have, of course, quotient rule in front of us. So it's low d high minus high d low over that low. So what's the low here? It's going to be x squared plus 1. Then we look at the high and then we get sad because it looks like it's not a very simple function. It's sine of x squared, so that means it does require the chain rule. But the chain rule shouldn't be too bad. Try to identify the inside and the outside function here. The inside function is sine of x. The outside function is the squared part. So we have to deal with the outside function first, the derivative of that one. So we're going to take the squared, drop it to the front. So it's going to be 2. We're going to keep the contents of the outside function the same. So that's why we're going to write sine of x here. Instead of taking the derivative of this one, we don't want to be too ambitious when we're taking derivatives. You only take one derivative at a time. So we're going to take the 2. We do have to subtract 1 from the exponent. Looks like I'm not going to have enough space here, so I'm going to rewrite it real quick. Y cubed equals x squared plus 1 times 2 sine of x. So again, I'm taking the derivative of the outside here. So I took the 2. I'm doing low d high. So you take the 2 down. And if you want, you should subtract 1. So if you want, you can write to the 1 here, but I'm not going to do that. And then we still have an inside function of sine of x. So you have to multiply by its derivative, which happens to be cosine of x. So this was the chain rule right here. We took the derivative of the outside function, 2, subtracting 1. We kept sine of x within these parentheses, and on the outside of everything, we multiply by cosine. Finally, the last part, we still are doing low d high minus high d low, where we were doing chain rule within the low d high minus high d low. So we have to finish low d high minus high d low. Low d high, so all of this was d high with the chain rule, minus high. You can just rewrite this. D low, what's the derivative of x squared plus 1? That's a little bit simpler, it's just times 2x. So it's times 2x. Finally, you divide by low, so it's x squared plus 1 squared. So again, these questions can get pretty complicated, but hopefully as you get accustomed to the chain rule, and the only way, in my opinion, to do that is do a lot of questions, you'll get used to multiplying by the derivative of the inside function on the outside of everything. Even if the questions are mixed up, chain rule, product rule, and quotient rule. So we're just going to do a few more examples just to make sure that we sort of have a general idea of what's going on. So let's do another one. I'm going to erase this. So let's do something a little bit more complicated. Let's do secant inverse. Then we're going to have, let's see, something quite crazy. Let's have x times e to the x. So here, we're still trying to mix up all the rules together because they're more fun when they're together. So let's see what we have here. It looks like we have an inside thing. It's x times e to the x. And then we have inverse secant, which is on the outside of everything, inverse secant. So it looks like our outside function is inverse secant, and our inside function is x times e to the x. But what's kind of crazy in this question is that our inside function is itself a product rule. So when we multiply by the derivative of the inside function at the very end of this question, we're going to have to do the product rule. So that's why this question is a little bit weird. Let me remind you of the derivative of inverse secant if you do not know it. It is one of those trickier ones which has multiple x's, but we know how to deal with that. Basically, we're just going to use both x slots. So let's start the question. So again, we identify the outside function in this case being inverse secant, so we take that derivative first. So it's going to be 1 over this thing, 1 over square root of something squared minus 1, where something is in the front. But again, Keep in mind that you do not change the inside function as you take the derivative of the outside function. So these parentheses will still be in the same slot. I'm still going to put x times e to the x and x times e to the x for every single x slot I have here. So that's how that worked. Finally, we multiply by the derivative of the inside function, but as I mentioned before, the inside function happens to be a product. So it's not like our previous question, which was chain rule within product. This one is product rule within chain rule, but we don't mind. Again, we're always multiplying by the derivative of the inside function. We look at this and we're like, oh my gosh, this is terrible. This is a product itself, but we're going to be okay. We're just going to multiply by the derivative of the inside function. In this case, it's a product. So it's going to be first derivative of the second plus second derivative of the first. So it's going to be first, which is going to be 1. Or let's write x first. It doesn't really matter. First times derivative of the second. So this e to the x happens to be a derivative plus, because we took the derivative of the second thing, now we have to take the derivative of the first thing. So it's going to be 1. Finally, we keep the same e to the x. Notice I'm being very careful with parentheses. Again, all of this needs to multiply this one right here. But that's how the chain rule works. You take the derivative of the outside function and you multiply it by the inside function. So let's do one last question. This was y prime, of course. But let's do one more question to finish this off. Let's do y is equal to, let's say we have something squared. We'll have 4 to the x squared. And then we'll have something crazy. What have we not done? Let's do inverse sine. So this is the hardest it gets, but as you do these questions, even if you keep combining these functions in crazy ways, you'll see that the questions don't get any much harder than any other question. You just do the same process over and over again. But in this case, it looks like we have 12 different functions here, so let's be careful. So first off, I want to identify what's the outside function with the inside function. So it looks like the outside function in this case is 2, nothing too crazy, but the inside function is very, very crazy. It's all of this. So the inside function happens to be a quotient. So as we're employing the chain rule, it looks like we're going to have to multiply by the quotient rule sometimes. But notice that each of the components of this quotient, the numerator and the denominator, have inside functions themselves. So as we're doing the quotient rule, we might have to do the chain rule. So let's start doing the process because this question is so complicated. So what's going to be y prime? Again, the first thing is the derivative of the outside function. So it's just going to be doing the power rule. So imagine this is just something to the 2. So what's that derivative? You take the 2, drop it to the front, 2. Then you don't change the contents of this guy right here. So it's the inverse sine of 3x times over 4 to the x squared. Then we're going to raise this to the 1. Again, because it's the power rule, take the 2, subtract 1, don't change the contents. Finally, we do have to multiply by the quotient rule, and this quotient rule is going to be very complicated. Hopefully I have enough space. But again, you're multiplying by the derivative of the inside function. The inside function happens to be a quotient. So let's do that. It's low. So what's low? It's going to be 4x squared. That one is not that bad. But now we have to do d high. And as we take the derivative of high, we notice that we have to do the chain rule because there's this 3x within the question. So what's the derivative of inverse sine? Let's erase this one. The derivative of inverse sine, if you don't remember, is 1 over the square root of 1 minus x squared. So where should we put this 3x? Well, we should put it where the x is. So it's going to be 1 over the square root of 1 minus 3x. And because 3 is also being squared, I'm going to be careful with parentheses, and I'm going to change that to 3x, all of that squared. So this right here, again, we're doing derivative of high, low, d high, where the derivative of inverse sine is this rule right here. But there is an implied function of 3x. So we need to multiply by 3 because that's the derivative of the inside function. What's the derivative of 3x? It's times 3. If you want, you can write it times 3 on the outside here, but because I need some space, I'm going to put the 3 here. So again, this is chain rule where the inside function was quotient, but the numerator and the denominator both have chain rules themselves. The derivative of 3x is 3. So that's low d high. We're halfway done through the question. Let's do minus high d low. So high is pretty easy, sine of negative 1, 3x. Then I have to do the derivative of low. Keep in mind, again, this is not power rule because this is a number to an x. This is the a to the x rule. What's the derivative of 4 to anything? Well, it's going to be 4 to that thing. Let's see if we can save a little bit of space here. So it's going to be minus sine of -1 3x. So I'm doing derivative of low d high minus high d low. What's the derivative of 4 to the x squared? Which is going to be 4 to the x squared times ln of 4, because that's the derivative of a to the x, a to that thing times ln of that thing. But unfortunately, we do have an x squared. That's the inside function in this small portion of this question. So we have to multiply at the very end the derivative of that inside function. So we're going to squeeze in, if possible, a 2x. This is getting too small, but I think I can squeeze in a 2x. Hopefully you can see that. Again, it's low d high, where this 3 came from the chain rule, minus high d low, where this weird 2x came from the derivative of x squared. Notice that I don't need to multiply by another 2x, because you never multiply by derivatives of things that are not originally in the question. X squared is certainly in the question, but we're not going to multiply by 2, for example, even if that's the derivative of 2x, because we introduced this 2x. Finally, at the very end, we do need to remember dividing by low. So it's low, so it's 4 over to the x squared squared. Usually on the AP exam, of course, this question probably wouldn't be this complicated, because it wouldn't be quotient rule within chain rule, but then the quotient rule itself has the chain rules. But hopefully you see that this process isn't too bad. You just take the derivative as they come. If you need product rule, you do product rule. If you need quotient rule, you do quotient rule. And the main thing is you do chain rule when you have inside functions that are not just x. So in this case, obviously this is not just an x. So when we take the derivative of the outside function, we need to multiply by the derivative of this guy. And even with these small chain rules, this 3x and this x squared, they're not just x's, so you do have to account for them, and you have to multiply by the derivatives when they come. But chain rule, again, is a very tricky thing, especially if you're just beginning. If you haven't done a lot of examples, that concludes this video. But of course, we have more chain rule questions on our channel. If you want, I'm going to link the Girls Teach Calculus video for chain rules in the description of this video. I would highly encourage you to watch that, where one of my former students practices a lot of chain rule questions. She probably explains it a little bit more patiently and more clearly than I do, so I would encourage you to watch that. Practice with her, as she does a lot of chain rule questions. She does chain rule questions with every type of function that we talked about: sines, cosine, inverse sines, e to the x's, a to the x's, and ln's. Then she mixes up chain rule within product rule, and product rule within chain rule, and chain rule within quotient rule, and quotient rule within chain rule. All of these various questions, where as you do more and more questions, you'll get better and better and better at this. So once you master the chain rule, and if you want to keep watching Girls Teach Calculus videos, we have just videos on straight up just review of derivatives, where just a bunch of derivatives that involves chain rule, quotient rule, and product rule, where if you want to watch those and practice, you will be able to find that on our channel as well. Taking derivatives is an art, and how do you get better at this art? You just keep doing them over and over and over again before you can do them in your sleep. Chain rule might be your enemy right now, but eventually chain rule will be your friend. You just do it 1,000 times, and after that 1,000 times, you're going to be able to learn this. So I encourage you to go back, maybe watch this video, or watch the Girls Teach Calculus video in the link below. Love, love, love chain rule. It's the best thing in the world. You're just going to do it so many times throughout your calculus journey that you eventually become good friends with the chain rule. But thanks again for watching Just Like Normal. Hopefully this was useful. If it was, please give us a like and subscribe. That definitely helps us out. Watch our Girls Teach Calculus videos on chain rule, and if you need to, go back and watch our videos on product rule and quotient rule. But for now, thanks again for watching, and I hope to see you next time, whenever that next time is. Thanks again.